Solve the following system of equations by matrix method. Now, the linear equations or system of equations can be solved by various methods. One of them is matrix method, and these equation that you see here is an equation of a line. For example, y equals mx plus c or ax plus by plus c equals 0. These are the lines. So when we have this y equals mx plus c or ax plus by plus c equals 0, then when we have x, y, z also, then we are talking about plane. So in order to solve this equation, we are essentially solving the intersection of these two lines. So how do we use the matrix for that? The way is, this matrix has to be formed. How to form this matrix using these system of equations? So step by step we will know how to solve this question. So first is how to write this equation first. The equation form is 5x plus 7i y equals negative 2. I am taking 2 on the right hand side. So constant has to be taken on the right hand side. Similarly, 4x plus 6y will be equal to negative 3, right? So now there's the coefficient of x and y. We will form a matrix. So the coefficient of x is 5 and 4. The coefficient of y is 7 and 6. This is the matrix. We call it as A. You can call it any letter. And what is x and y? This is x and this is y. This is we call as an x matrix, x. And this is equal to, on the right hand side, what is there? Negative 2 and negative 3. Okay, so this is ax equals b. This is our matrix, ax equals b. Now in order to find out x, what do you get? We will multiply both sides by a inverse. So a inverse is I, on the right hand side it will be a inverse b. So x will be equal to a inverse b. This is the whole, you can say the summary of solution. So there are various things you need to know. You need to know how to find out the A inverse. You need to know how to find out the matrix multiplication, the transpose, the cofactor. All these are the basics you need to know before even going to solve the system of equation by matrix methods. So we'll multiply this, we'll equate this, and we'll try to find out the solution. Okay, this A, because we need A inverse, so adjoint will be what? This is 2 by 2 matrix, so it's quite easy. 5 and 6 we are exchanging, so this will be 6, this will be 5. And 4 and 7 will change the sign, and this is your adjoint. This is for just 2 by 2. Now, after finding the adjoint, we have to divide it by the determinant, because A inverse is nothing but adjoint of A divided by the determinant of A. So the determinant will be 5 into 6, that is 30, minus 7 for the 28, so it will be 2. Now before that, let me tell you one more thing. How do you know that the line are going to intersect? How do you know the lines are not parallel, or though both lines are same? So they are parallel, they are same. If they are same, they are parallel, you are not going to get any solution. You will get to a solution only when the intersection point is there. So the determinant should not be equal to 0, it has to be a non-zero value. Since we have 2, so we can go ahead. So what will be A inverse? It will be adjoint of A divided by the determinant of A. So this will be, determinant is 2, so I am dividing it, and the adjoint I am writing. So this whole is your A inverse. The next one is to multiply by B. What is B? On the right hand side, you see this is negative 2 and negative 3. So first is 2 by 2 matrix, second is 2 row 1 column. So you will only get a matrix with only 2 rows. So 6 into minus 2 plus minus 3 into minus 7. This will be first value. First row with first column and second row with the first column. Now minus 4 into minus 2 plus 5 into minus 3. So 1 by 2 will apply later. So 6 to the 12 minus 12 and this is going to be plus 7 3 is 21. This is minus 4 2 is 8, then minus 5 is 15. Now 21 minus 12 is 9. So you can write 9 here. 8 minus 15 is minus 7. So 9 and minus 7, that is what you get. But you have a half also. So divided 9 by 2 and minus 7 by 2. So this is your x and y. So x is 9 by 2, y is negative 7 by 2. So this is how you are going to solve linear equations or system of equations by metric method, 2 by 2. Okay.